Good morning, good morning, good morning. I'm going through the preparatory examination 2025. Today I'm going through 1.3, question 1.3. Remember yesterday I covered 1.1 and 1.2. I'm still under the same topic, that is climate and weather. So I'm focusing only on 1.3. Then the next day I'll also do 1.4. So let's go through the question. The reason why I'm trying to slow down a bit is to make sure that I do not confuse you or I don't load you with a lot of information. I want you to understand concept by concept so that a lot of things doesn't build up at the same time. So this is going to help you to grasp the concept, to understand the basics of the concept. Like today, I'm going to cover mid-latitude cyclones. So by going through the questions, I'll also add some more information just to make it more comprehensive. So let's go through the question. Refer to the infographic. I think when you talk about an infographic, you can see what we have. We have got the text, we have got the what? The satellite image, we also have this information. This is what makes an infographic. So it means all this information we are supposed to use to respond to the questions that you are going to be asked. So whenever you have got an infographic, guys, it's a way of giving you some clues. It's a way of giving you the answers indirectly, because you have already learned about mid-latitudes. The only thing that is left is for you now to apply what you have learned, to apply what you know about mid-latitude. So this is easy, guys. Whenever you come across a question with an extract, with a sketch or anything, guys, you are given clues on how to answer the question or to respond to the question. The only thing that is left for you is just to totalize. I would say just to totalize, get all the marks. I mean, then we are getting all the marks on a silver plate. Okay, let's go through the question and see how we can unpack, how we can make it easier for you to understand. Refer to the infographic of mid-latitudes below and answer the following questions. Okay, so when you hear the word mid-latitude, what comes to your mind? I think let's start with that. When you hear the word mid-latitude, what comes to your mind? I'm going to explain it through this way. Okay, I'm going to take you back to grade 11, global air circulation. Okay, so something like this, of course, comes to your mind. Okay, the reason why I'm doing this, I want you to understand where this mid-latitude actually is more active or takes place. Okay, 60 degrees north, this is where you've got your 90 degrees. This is where you've got your 30 degrees south, 60 degrees south, then you've got your 90 degrees south. So the first thing that you should be able to understand when it comes to mid-latitude, guys, where do they okay? Of course, I can start with your identification of the world pressure belts. You've got your low pressure, you've got your high pressure in the subtropical, high pressure both north and south of equator. You've got low pressure in the sublow, you've got low pressure in the sublow, you've got high pressure on the polar high. So the first thing, the foundation of mid-latitude is for you to understand the global air circulation. So you've got polar high, we have got the polar high here, we have got the subpolar high, we have got the subtropical high, then we have got the equatorial low. We also call it the ITCZ. Okay, same applies as we are going downwards. So we are saying now, these cyclones they occur in the mid of the latitude, which means between 30 degrees north and south to 60 degrees north and south. That's why we call them mid-latitude or temperate cyclones. That's what we call, that's the other name that we call them. Okay, so they occur between 30 degrees north and south to 60 degrees north and south of the equator, which means this is where you find this mid-latitude. Same applies north and south. This is where you find this mid-latitude. Okay, so this is where you find this mid-latitude. So if you look at our pressure belts, of course, here we have got the tropical easterlies, here we have got the tropical easterlies, here we have got the westerlies, tropical westerlies, there we have got the polar easterlies, Then we have got the polar easterlies. So we have got the pressure belts, low pressure subpolar. We have got the polar high at 90 degrees north and south. We have got the subpolar low at 60 degrees north and south, both north and south, where that the subpolar, okay, say subpolar low, not high. Subpolar low pressure. Then you've got the subtropical high pressure, 30 degrees north and 30 degrees south. Then you've got the equatorial low, which is also known as the doldrum, which is also known as the intertropical convergence zone at 0. So we have got the tropical easterlies, 0 to 30, tropical easterlies, 30 to 60, we have got the westerlies. Then 60 to 90, we have got the polar easterlies, both north and south of the equator. So once you know this thing, you need to know where do we have this mid-latitude. It's in the middle of the latitude, which means from 30 to 60, this is where it takes place. So here is a low pressure, which means we have got the cold wind from the polar high. Then we have got the warm from what? From the subtropical high. They are separated by a polar front, which is at the subpolar low. They are separated by a polar front, which is at the subpolar low, which means the movement of this mid-latitude is driven by the westerlies. It moves from west to east, or it moves eastwards. It moves from west to east, or it moves eastwards. That's how it moves. It moves eastwards because it's driven by the westerlies. You have got westerlies in this belt. We have got westerlies. Okay, we have got westerlies here between 30 to 60. So this is what drives the mid-latitude. That's why it moves from west to east. Okay, let's go through our infographic now. I wanted you to just have a better understanding. Okay, Cape Town in South Africa, AP, South African city of Cape Town and surrounding areas were hit. They were hit by more storms on Thursday that ripped off houses and caused widespread flooding. So already from what I'm reading, you can actually detect the impacts of mid cyclones that comes or that are associated with floods. So already you can just read into the text that these are the impacts that are actually being highlighted of this mid-latitude cyclone that are associated with floods, forcing at least, which means there's people displacement, forcing at least 4,500 people out of their homes and damaging at least 15,000 structures, authorities say. This is something that has happened due to the mid-latitudes, okay, or the cold front that was experienced in Cape Town. Okay, the devastating weather began a week ago, which means now it's suggesting that the movement of the wind, a cold front toward Cape Town, it resulted in these damages or in these impacts that have been highlighted. Okay, multiple cold fronts have battered the region on the southern tip of Africa since late last week, which means the devastating effect of the cold front that has been felt is been for a week now. Okay, bringing record rainfall, gale force winds in some parts. So another thing is the cold fronts. They are associated with the heavy torrential rainfall. They are associated also with very strong winds. That's something that has been highlighted from this text. City authorities said the bad weather was expected to continue until the weekend and possibly the next week. So we are saying now whenever Cape Town is hit by a cold front, it's not something that happens in a few hours or that happens in a day or two, then it's over, but it happens over a long period of time. We have heard that it's going to continue for the next week. It has been happening for a week. You understand? Okay, so what do we have on this satellite image? You can see the satellite image. What do we have? You can see, of course, this is, okay, this shows the type of clouds. Why here, normally the cold front is associated with clouds of vertical extent. That is your cumulonimbus clouds, which results in heavy torrential rainfalls. Okay, so you can see also with the movement, of course, you can see with the movement, it shows you that it's within the movement. You can see with this, it moves, that it's moving in a clockwise direction, which means it's in the southern hemisphere. That's where South Africa is. Okay. Cross-section through the mature stage of a mid-latitude cyclone. When it comes to the stages of the mid-latitudes, what do we have? We've got the initial, the development stage, we have got the mature stage, then you've got the occlusion stage. So you have to know the stages as well. Of course, the initial, this is where obviously in the initial we only have cold air from the polar front, which is high pressure, and also warm air from the subtropical high pressure, also separated by the polar front. This is the initial stage, which means they are just separated by a polar front, because there are different air masses with different characteristics in terms of temperature, in terms of moisture content. This is cold and dry. This is warm, is also coming from the subtropical. It's warm and moist, of course, it's coming from the subtropical. But you know, in air mass, as it passes over the Earth's surface, it also absorbs. The temperature is transformed, is changed, the moisture content is also changed. So as it is moving, you find that it is warm, it also absorbs moisture. That's what makes it warm and moist. So that when it's warm and moist, this one is cold and dry. So these have got different densities. They have got different densities, which means the other one is going to be heavier, which is going to uplift. The warmer and moist results in the development of clouds, vertical extent, and so on and so on. What comes to your mind, obviously, is your frontal rainfall, just in general. Okay, let's go back now. Cross-section of the mature stage of the mid-latitude. So what do we have here? Direction of movement. Look at the direction in which it's moving. It's moving from west to east. It's moving eastwards. That's what is being shown here. Okay, then what do we have? You can see also the warm air. As soon as the cold air, okay, separated by a cold front, which means there is massive upliftment of our warm air. You can see it's rising. The warm air is rising in terms of the direction. When it rises, it cools, condenses, results in the formation of clouds of vertical extent. That is our cumulonimbus clouds here. Then we have got rainfall. So there's massive upliftment of the warm air. Warm air by its nature is very light. Warm air holds more moisture. So when it's uplifted, of course, it cools. As it cools, it condenses, clouds form, especially clouds of vertical extent when we talk in reference to the cold front, which result now in more rainfall or heavy rainfall that is forming. You can see here. So here we can have where we have got our cold air here, which means there is a steeper pressure gradient here. Behind the cold front, there is cold air. There's a steeper pressure gradient. In between here, we have got the warm sector. That's why we have got this warm air that is being uplifted. As soon as it uplifted, it rises, cools, condenses, and clouds form. Then here, behind the warm front, you've got warm air. Here is cool. Here it's cold, cool. Of course, you have to know the position of your cold, warm sector, or warm air, and also your cold air. You have to know the position of that. This is your warm front. This is your cold front. Behind the warm front, there's warm air. This is your warm sector. Ahead of the warm front, there's cold air. Okay? Behind the cold air, there's what? The cold front, there's cold air. Ahead, there's warm. So this is your position of your warm sector. That's why you've got your warm air. That way you've got your very cold. Yes, cold. Yes, very cold. Okay. Provide the reason for the article, from the article, for the record rainfall experience around Cape Town. What is the reason, okay, for the rainfall that was experienced in Cape Town, around Cape Town? So you can see what we have. The reason here, multiple cold fronts. You can see here, multiple cold fronts have battered the region. Multiple cold fronts have battered the region on the southern tip of South Africa since yesterday, bringing record rainfall and gale winds in some parts. So that is the reason the multiple cold fronts have battered the region in the southwestern tip of Africa since late last week. That will be your answer. It's coming from the extract, okay? So from the infographic, so we got that our landmark. Identify the cloud type indicated in Y in the image. Obviously, I've talked about these clouds, okay? Why? This is a cumulonimbus cloud. Remember, this is a cold front. This is a cold front. This is your cumulonimbus cloud, but I'm referring to Y here. This is a cumulonimbus cloud. You know, the cold front is associated with the cumulonimbus cloud, which is a cloud of vertical extent, okay, that formed as a result of the massive upliftment of warm air by cold air. As it is uplifted, it cools, and condensation takes place, clouds of vertical extent come. This is your cumulonimbus cloud. That is your 1 mark. We have got 2 marks now. We're moving. Account for the development of the cloud type at A, at Y. How do this cloud type develop? That was the question is talking about. I've already explained that the rapid upliftment of warm air due to the steep pressure gradient at the cold front. We are now saying that there is steep pressure gradient here, which caused the rapid upliftment of the warm air, and this is what results in the formation of these clouds. That's basically what we are talking about. You get your 2 marks. State the general direction of the movement of the tropical cyclone. Remember, here is there. This is the general direction from west to east, or it moves eastwards. This is the general direction movement of the clouds. It's moving from this towards this direction, which is west to east. Same applies here. I think I've also explained that we have got here, that's where the mid-latitude is taking place. It's driven by the westerlies. It's moving from west to east. Okay. Then give the reason for your answer. I've already said the reason for the answer. It moved from west to east. It's driven by the what? It's driven by the westerlies, or the system moves in the direction of the prevailing winds. The prevailing winds that we have here, westerlies, is moving in the eastwards. It's moved from west to east. That's basically what we are talking about. Then 1.3.6, explain how the general direction of the movement of mid-latitude cyclone in question 1.3.4, we have said it moves eastwards or from west to east, result in the flooding referred to the article. 1.3.6, we are now saying now the west to east movement over the Atlantic Ocean carrying large amounts of water results in heavy rainfall. That's number one. West to east movement over the Atlantic Ocean carrying large amounts of water results in heavy rainfall, or continuous formation of cumulonimbus clouds due to multiple cold fronts, cold fronts causing excessive rainfall, or continuous heavy rain from multiple mid-latitude cyclones saturates the soil, leading to more flooding. Saturate the soil, leading to more flooding. That's basically what we are talking about. Then draw a labeled view of the cross-section. Draw a level view of the cross-section from A to B. From A to B, of course, from A to B, they must be shown in the following. Okay, what is supposed to be shown? The position of the cold front, position of the warm air, and position of the cold air. Okay, so we have got, remember, it had said that is the mature stage. So what we have on our mature stage, we have got something like this. Okay, we've got something like this. We are going to show that this is a cold front. We are also going to show that this is a warm front. Where do we have? We want to show position of the cold front. So this is our cold front. Where is our cold air? Our cold air is here. Okay. Where is our warm air? Our warm air is here. So this is the position of our warm air. This is the position of our cold air. And this is the position of our cold front. Of course, this is a plan view from okay, let me say from A to B. So it means this is a plan view from A to B. This is going to be our answer. Now let me cover this part. Okay, this is going to be, okay, this is our cold front. Of course, I have pointed, this is our cold front. This is our warm air, or our warm sector. We call it a warm sector as well. Okay, this is our warm sector, and this is our cold air. That's what you're supposed to do there. You're supposed to label. You get your mark for 1 mark for drawing the plan view correctly. I've drawn it correctly, which means I get a mark for that. I get a mark for labeling the warm air, the cold front, and also the cold air. Then which means you get all your marks. This is how simple it is, boys and girls. This is how simple it is. Like I've emphasized, please, when you are given the infographic, guys, you are just being, given clues. Okay, you are being given clues. This is you are being given the answers indirectly. So this should actually make your life easier. Okay, thank you.